Section 2.4, limits at infinity and horizontal asymptotes. We're going to go back to last year with some memories from pre-calc about the end behavior of graphs. At the end of my talking, I would just pause the video to jot this down, but listen first. Options for end behavior include your curve flattening to a definite value. So last year you would have talked about these as horizontal asymptotes. So if you look at my function f of x, it is flattening as I approach infinity. It's flattening to a height of 3. As f of x approaches negative infinity, you can see that it's also flattening to a value of y equals negative 2. Please note that it is okay to cross here this horizontal asymptote because it is an imaginary line that guides the function to a specific height. It's not really a line in the graph. That's why it's dotted. So please take note of that. If I take and approach infinity on the function f of x, I'm approaching a height of 3. If I approach negative infinity, I'm approaching a height of negative 2. So what does that mean when I'm flattening towards a specific value and I have these horizontal asymptotes? Then we write them as the equation of a horizontal asymptote. So we have y equals negative 2 is one horizontal asymptote, y equals 3 is the second. So limits going to infinity and negative infinity, if they produce a definite value, correspond to a horizontal asymptote in the graph. Part B, your curve is either increasing or decreasing without bound. I picked a cubic because it exemplifies both behaviors. So in this case, as we approach infinity, that's heading to the right of the graph, the function itself is going down indefinitely, so we would say that it is approaching negative infinity. If I take my cubic function displayed here, I approach negative infinity. That means going to the left. What's the behavior? It's heading up. If it's increasing without bound, it's a positive infinity. The last scenario for end behavior is curve oscillation. So this one I tried to draw a representation of a sine curve. So the sine curve will keep oscillating back and forth between that 1 and negative 1. You could have easily drawn a cosine curve. So if it keeps oscillating, it's not approaching one particular height. It's not approaching one particular height. The limit does not exist. I'm going to do 2 questions with you. We'll save the rest for class time. 2 different approaches for these infinity limits. The first, which you probably did in pre-calc, was to say if I'm going to infinity, then the behavior of the curve is decided by, when I look at this quadratic, it's decided by just the highest degree term. So really, when I'm approaching infinity, I focus on the highest degree term because that dictates the behavior of the curve. Or think of it in terms of money. If you are increasing your money without bound and you add $1, is it really significant? If I subtract 8 times that number, what is that in comparison to the quadratic? The quadratic function grows so much faster than this linear function. So therefore this one dominates. That's why we pick it. In the denominator, who's the dominating term? The 6x squared. So the answer to this, when we do some algebraic analysis, is to cancel the x squared, and we would say 1/2. Because I have a definite number, don't forget, the limit here is telling me that the graph of this rational function has a horizontal asymptote at 1/2. If the visual conception is not working for you, the other methodology for the infinity or the negative infinity is to take and divide through by whatever is the highest degree term in the whole problem. You do it to every term. X over x squared, 6 over x. divided by x squared over x squared plus 36 over x squared. Sorry, I forgot my squared up here. Simplifying, I have the limit as x approaches negative infinity, 1 over x plus 6 over x squared divided by 1 plus 36 over x squared. What happens when I analyze going to negative infinity is I think about the rational parent function from last year. If you know this graph, then as you go left on the graph, this graph is approaching a horizontal asymptote of 0. If that graphing doesn't help you out, think of it this way. 6 divided by, start with negative 10 squared. That's 100. 6 divided by negative 100 squared. 6 divided by negative 1,000 squared. 6 divided by negative 1,000,000 squared. What is this graph approaching? 0. Over 1, the constant, plus 0 for the same analysis as I did here. We end up with a limit value of 0 for this limit. Oops, sorry, I forgot to move my paper, so there it is. Okay. So if you want to pause the video, you can pause it, go back and write down this information that we talked about in the beginning, so you'll have it for your notes. And then here is 2 and 3, and you can pause it and jot those down. And again, we'll do the rest in class.